So we just got done taking our Unit 4 test over the triangle congruence, and what we're going to do for just a few days is just do some more Algebra 1 review. It's probably not going to be a full week that we do this before we move into our next big unit. So yeah, just some Algebra 1 stuff really that we're going to be working on for the next few days. Okay, so today what we're going to talk about is slope of a line, okay? So how do we find slope of a line?
Train tracks.
Okay, change in y over change in x to get what you're saying. Okay, so here's the formula. It's y2 minus y1 over what?
X2 minus
Yep, x2 minus x1.
Isn't there another way to do it though?
Yep. So this is the formula. We'll use the formula whenever we have one situation. Then what's another way to find slope?
Rise over.
There you go.
MX plus B.
Okay,
Did you?
the mx plus b is actually the form of a slope-intercept line. We'll talk about that in like 2 days or something, probably on Monday or something like that. But in mx plus b, the m is the slope. Okay, so the rise, okay, is how far up or down it goes. And then on the bottom, it's going to be how far to the right. Some teachers do this differently. This is the way I like to do it. The top number is the up-down movement. The bottom number will always, the way I do it is we start at the left-hand side, working our way to the right. Okay. So, I'm going to use this whenever I have the picture, okay? Like, what I mean by that is like this. I'm going to use rise over run whenever I can see it on a graph. Okay? I'm going to use the formula whenever all I have is the numbers or the coordinates. All right? Like down right below here. So if I have the picture, the graph, I'm going to use the rise over run thing. If I just have the coordinates, I'm going to use the formula right there. So on these, I'm using rise over run. So let's think about to get from J to K. Think about our rise to get from J to K. So how far up, just straight up, do we have to go to get in line with K? How far up?
5.
You go up 1, 2, 3, 4, 5. Okay? So we rise 5.
4.
And then how far do we run? 1, 2, 3, 4. So the slope of that line is 5/4. Okay? I could write m equals 5/4.
So right, if you go left, it's a negative.
Well, not necessarily. And that's the reason I always start at the left-hand side, like I started at J's, the further left point, and working my way to K.
So does it matter where you start from there? If you start from L?
Right? I'm always going to start at the point on the left-hand side. So here with L and M, I'm going to start at L because it's the one that's further left. All right? So, starting at L to M, what's my rise? How far do I have to move up or down?
6.
1, 2, 3, 4, 5, 6. Okay? But I'm going down 6, right? So that's where the negative part comes in for me, is always in the rise, whether it's going up or down.
So we're going down, we're being negative.
Yep.
Going up, we're going.
If you're going down from left to right, it's going to be negative. We're going to talk about that more in just a little bit. Okay, so what's my run now? How far right do I go? 1, 2, 3. So negative 6 over 3 is my slope. Now, if I can simplify it, I want to. Okay, so there's 2 different ways. So negative 2 over 1, or all the way down just to negative 2. All right, on this next one, on C. Okay, what is the rise? How far up or down do I go to get from N to P? 0. There's 0 rise. What's the run?
0.
1, 2, 3, 4, 5, 6, 7. Okay, type that in your calculator real quick. Do 0 divided by 7. See what that gives you.
0.
What does that equal? 0. The slope of this line is 0. Slope of that line is 0. Okay, now let's look at this one. To get from Q to R, what's the rise? 1, 2, 3, 4, 5. What's the run? Is 0. There's no left-right movement. Type that in your calculator. Do 5 divided by 0.
5.
Type it in. Type it in your calculator. 5 divided by 0. See what it tells you. Type it in.
It gives me undefined.
What does it say? Okay, it does not say 0. I promise you that. It says undefined. The slope of that line is undefined.
I told you.
Okay, let's talk about why that's true. All right, think about this. Okay, what division does. So in division, what you're doing is you're saying, okay, this number on bottom times some number to give me the number on top. So 7 times what is 0? 0. 7 times 0 is 0. Okay? So that works. That gives you 0. Here, okay, if you think about that here, all right, the bottom number times something to give you the top number. Okay, 0 times what gives you 5? It's impossible. You cannot multiply 0 by anything and get 5. Because 0 times anything is going to give you 0. So basically what your calculator is saying is, hey, dummy, you cannot multiply 0 by anything to get another number unless it's 0. Okay? So that's why this is undefined. It does not work. All right. Now, like I said, when I have the picture, like we did, I use the rise over run. But on these, where I just have the numbers, the coordinates, I'm going to use this equation right here. All right, so let's label it. This is going to be x1, y1, and x2, y2. Okay, so let me just rewrite the formula right here so we can see it. y2 minus y1 over x2 minus x1. So what is my y2 value? Is negative 5. Okay? Now notice there's a minus built into this formula. So I'm putting a minus here regardless. Then what's my y1 value? It's negative 2. Okay? Now my x2 value. Guys, need y'all to pay attention, please. What's my x2 value? Is negative 3 minus, what's the x1 value? 6. Okay, now you can just type that whole thing into your calculator and see what that gives you. I'm going to go ahead and work this out real quick. Okay, so what happens to these two negatives right here? Well, they don't cancel. Turn into a plus. So what's negative 5 plus 2? Is negative 3. And what's negative 3 minus 6? Is negative 9. And then negative 3 over negative 9 simplifies all the way down to positive 1/3. If you just type that whole thing into your calculator, this right here, it'll do all the math for you. It'll do the simplifying and everything. Should just spit out 1/3 for you.
I want to try to do it.
Okay, next one. So we have x1, y1, x2, y2. Which, again, by the way, this is all Algebra 1 stuff, so y'all are in geometry. You definitely have seen all this before. This should just be pure review. All of y'all did awesome on the Algebra 1 star last year, so
We did?
yeah. There was 90-something% that passed it in the first shot, so pretty good.
No, you were.
All right, so negative 2 minus, negative 3, and then negative 6 minus 8. All right,
I negative 1 over 14.
and that's what it's going to give you, negative 1 over 14. Okay. All right, next one we have x1, y1, x2, y2. So I've got negative 3 minus 2 over 4 minus 4. Okay, so let's just, without putting anything in, notice on the bottom we're going to have 4 minus 4. That's going to give us what? 0. And remember up here, whenever 0 is on the bottom, what's it going to give me?
Undefined.
It's going to tell me it's undefined. Okay? The slope on this line is undefined. That would be a vertical line right there. Okay? On 1D, we're going to have x1, y1, x2, y2. So you're going to have 3 minus 3 over 4 minus negative 3. Now notice on top, you're going to have 3 minus 3 is what?
0, so it's going to be 0. Then.
0. Whenever there's a 0 on top,
That's going to
gives you a slope of 0. So this one has a slope of 0. Okay, so in general, if you're going uphill from left to right, what type of slope is this? This is positive slope when it looks like this. When you're going downhill from left to right, what is that?
Negative.
Negative. The horizontal line, 0 slope, and vertical line
Undef.
is undefined slope. Okay, and some of y'all may have learned this, I don't know, but there's a slope tree where you have positive, negative, 0, and undefined. I don't know exactly how they teach that, but it's something like that.
I thought we did that this year.
Slope tree.
I swear we did.
Yeah.
I swear we did that this year.
Who's done?
Okay, now, something we're going to do with slope is talking about parallel lines and perpendicular lines. Okay, if two lines are parallel, they just have the same slope. Okay, guys, that's enough, please. Okay, if two lines are parallel, they're going to have the same slope, which just is common sense. That's just common sense. The perpendicular slope thing isn't something that would just necessarily come to you. Okay, so if two lines are perpendicular, their slopes are what we call opposite or negative, however you want to say it. Okay, I'm just going to say opposite reciprocal.
What is reciprocal?
Okay, we're about to talk about that in just a second. So if two lines are parallel, they have the same slope. If two lines are perpendicular, and what does perpendicular mean again? What does it mean to be perpendicular? They cross, but it's something more specific than that.
They're the same?
Not the same. Two lines are perpendicular, they cross, but it's not just any intersection. They make a certain type of angle. They make a 90-degree angle. Okay? All right, so let's talk about the phrase opposite reciprocal. So the opposite means to change the sign. Means they have different signs. And a reciprocal means you flip the fraction. So two things. They're going to have different signs, and they're going to be flipped from each other. So what I mean, but let me just give you an example. So negative 3/4.
So 4 over negative 3.
Okay, and we changed the sign, so it's going to be positive 4/3. They're going to have different signs, and you flip the fraction. So see, the first one was a negative, the second one's positive, and the first one was 3/4. Now we've got 4/3. So if you had a line that had a slope of 7/8, what would be the negative reciprocal of that? Negative 8/7. Okay, so if two lines are perpendicular, this is the way the slope of those two lines are going to look. They're going to be opposite reciprocals of each other. So what I want you to do is, we're not going to do 3a, but I want you to take this 3b and I want you to plot those 4 points on that graph right there. Take those 4 points, A, B, C, and D, and plot those 4 points on that graph. Okay, so we have 3, 6. That's A. B's at negative 9, 2. C is at 5, 4. And then D is at 2, 3 right here. Okay, so what looks like is happening with those two lines? Well, yeah, about like that. Yeah, I can't get exact, but so what do they look like? They look like they're parallel. But what I'm going to do to check on that is I'm going to look at the slope of them. Okay, so let's look at the slope of BA. So I'm going to do my rise over run thing. So to get from B to A, how far up do we go? You go up 4, and how far over do you go? 5, 6, 7, 8, 9, 10, 11, 12. Okay, can I simplify 4 over 12? Yep, to 1/3. Okay, now on this CD, how far up do we go? 1, and we go over 1, 2, 3. Do these two have the same slope?
Yes.
Okay, they are the same. That means that these are parallel. And it's not because they look like it, it's because of this right here. Okay, on this next one, I want you to plot these points. So we're going to have let's see, we're going to have A at 1, 6. We're going to have B at 4, 2. We're going to have C at 1, 2. And then we're going to have D at 5, 5. Okay, plot those 5 points on there. Or 4 points, sorry.
I forgot what that point is called where they intersect.
The point of intersection.
Is it Scott?
Yeah. Okay, what does that look like is happening there probably? Does that look like they're parallel?
Yeah.
Does it look like they're parallel?
No.
Does it look like maybe this is a 90-degree angle right here?
Yes.
It does to me. So to me, those look like they might be perpendicular. So let's check and see. All right, let's find the slope of CD. So to get from here, how far up do we go? 3. How far do we run? 4. So the slope on that line is 3/4. Okay, now let's check the slope on line AB. So it's going downhill. It's a negative slope. So we go down 1, 2, 3, 4. Okay, so down 4. And then how far do we run?
3.
1, 2, 3. Yeah, that color's terrible. Negative 4 over 3. Okay, so what do I notice about those two slopes right there?
Opposite.
Okay, those are opposite reciprocals of each other. 3/4, negative 4/3. I mean, that's the exact example I showed you up there. So that means, yes, these are perpendicular. That is exactly a 90-degree angle right there. I'm assuming that everything's square on here. Okay, what if you had a line that had a slope of, let's say, negative 2/3 and another line that had a slope of, 4/5? Okay? Would those two lines be parallel?
No.
Would they be perpendicular?
No.
No. So if you had two lines like that, they're not parallel and they're not perpendicular. So that means that they are going, if you had two lines with those two slopes, they are going to cross each other, but they're not going to make a 90-degree angle. It's going to be some angle besides being 90 degrees where they meet up. Okay,